Hi everybody and welcome. In today's video we're going to be taking some notes on some specific ways that we can manipulate logs in order to solve them. So your goal after watching this video will be to understand two different methods that both allow us to solve for final answers for logarithmic equations. A couple of quick things to note, just general information purposes before we jump into doing these strategies and doing these methods of solving, are some of the basics that we don't want to forget. So the first thing is, in a log, we have to make sure that we have positive real numbers. So anything that gives a overall negative value for a log, so let's say if this like m value, the overall value inside of the log that's negative or even equal to 0, those aren't going to work. Those won't be part of the domain. So the domain of a log is anything after 0 all the way up to infinity, unless that log's been shifted. So we want to make sure that we are adhering to that domain when we're solving, but also after we solve, we want to go back and check our answers and make sure that they're within the actual domain. So first things first, we've seen this in a few examples before. If we have two different numbers, m and n, and we see logs that have the same base, then we can just set those equal to each other. So the contents of the two logs with the same base that are equal to each other, the insides are equal to the insides. So whatever that might be, you can set the insides equal to each other if you have the same base and if it's just logs on each side of the equal sign. So it works both ways if you have m equals n, and it also works if you have the log equals the log. This goes back and forth. So you can use this to solve this, or you can also use this to solve this. So just a quick reminder, an example that you might see would be like the log base 5 of x equals the log base 5 of 7. You can use this to say, okay, I know that x has to equal 7. Just taking just the inside and just the inside. That's all. That's all that that property is saying, is that if you just have a log on the left and just have a log on the right, the insides are equal to each other. So outside of those ones where you already have logs already equal to each other, oftentimes you're going to have other properties, other things that complicate these log equations. And when we have that, there are two different strategies that we can use. So the first method is when every term is a log and those logs also have the same base. So here are some steps that will help you solve. So first, what you want to do is combine the logs on both sides. And then second, you're going to want to use the property of logarithms that we just did above. And we can use this to eliminate the log. So the benefit of this is if you can just get one log on the left and one log on the right, we can just solve the insides and ignore or eliminate the logs. Lastly, we can solve the equation that generates. And we also have to make sure that it is in the domain. So double checking to make sure it doesn't give us an overall negative log. So a first example here, all of these logs in the first equation are of the same base. Remember, if there's nothing written there, it is just an invisible 10 that's hiding. So all of these, the common log, base 10, they're all good, all set. We have multiple of them though, so we want to combine them. So using our properties from 4.4, if we are adding two logs, we can get a log that allows us to multiply the insides. So if we have addition of logs, we can multiply what's on the inside. So we can have x plus 2 times x minus 2. And all of this is going to be equal to the log of 2. So the nice thing, again, looking back at our property from before, we have log equals log with nothing else. So we can set the insides equal to each other. So we can have x plus 2 times x minus 2 equals just 2. So by doing that, this now puts us in a situation where we can solve. So what we're actually going to have to do is take this problem right here, x plus 2, x minus 2, and multiply. So you can use FOIL, you can use the box method, whatever method you like to organize your work with the most. So here we'll get x squared minus 4. And then we just continue to solve. So a couple of different options to solve this one. Completing the square, quadratic formula, box method. We can even take our 4, move it over to the other side, get x squared equals 6. And then doing this, we can take the square root of each side. So the root of x and the root of 6. So we'll get x equals plus and minus 6. So those would be the 2 answers. Now what we have to do is go back and double check and make sure that positive 6 and negative 6 don't give us any negative logs. So if we plug this in, so log of 6 plus 2 plus the log of 6 minus 2, and again, this is just from the original equation. We're just plugging in our values, goes the log of 2. So it looks like we have positive log here, positive log here, positive log here, all good. Plug in negative 6, so the log of negative 6 plus 2 and it actually looks like minus 6 minus 2, that's a negative answer. And then minus 6 plus 2 is also negative. So for both of these, it doesn't work. So we can say that this answer is not in the domain. So because of that, the only answer that's tested and actually works is x equals 6. So the solution to this question overall is x equals 6 because we know it's in the domain and we use those properties to go through and to solve it. So as always, when we are working through these ones, we want to be sure, combine them, set them equal to each other, and solve. The only actual log property that we used today was right here. This step is the log property. This step is the log property. Everything else from there, that's just going through some Algebra 2 factoring and solving and properties and mechanics there. So I would say really focus on those 2 steps in yellow. Those are the new steps that we're introducing. And then we'll get, as always, more practice with factoring until we are feeling good and confident and comfortable solving those types of questions. For our second equation here, similar type of idea. So I would encourage you, practice that question. See if you can get the steps to make sense. One thing to point out, this is a subtraction sign, so you'll see some division instead of multiplication there because of the subtraction sign. But otherwise, properties are the same. You want to get to this point right here where we have 1 log on each side, and then you can eliminate the logs after that. So the whole purpose of this method of solving is to get logs alone on each side and to eliminate the logs as a result of them being alone. All right, so next we have a different type of question. So it's not always possible that we can just have logs on each side. Sometimes we have more complicated terms. And when we have more complicated terms, we have a different method that we can solve. So this method specifically applies to not all terms have logs, so only some. So the best way to go, if that is the case, is we want to get all the terms with a log on one side. So we're trying to isolate logs to just their own sides. There's going to be a log side, there's going to be a number side. So be careful with that, moving things around. Make sure to use the inverse property to move from one side of the equation to the other. Second, combine the logs that are on that side. So anything that can go together should. So if you have logs of the same base, put them together, you absolutely should do that. The third thing here is, when possible, switch to exponential form. This will eliminate the logarithm. We like that. That makes it easier to solve. And then we can solve the equation that results from that. And just like we did before, we have to make sure to check our answer to make sure it is in the domain. So either of these questions on the bottom are good examples of this. So we have some logs and some numbers. So get the logs alone. So if we have 4 plus log base 2, well, we want to get that 4 out of there, get the log base 2 completely alone. So the opposite of positive 4, we can just subtract 4 on both sides. So log base 2, 2x plus 1, and then 7 minus 4 gets us 3. So that was get logs on one side. That was step 1. Step 2, combine any logs. Well, there's only 1 log, so nothing to combine. So step 2 is good. Step 3, switch to exponential form. Okay, so we have our base, which is 2, our exponent, which is 3, and our answer, which is 2x plus 1. So here, 2 to the 3rd power is 8. 2x plus 1 is left over, and then we can just continue to solve from here. Remember, if you ever have just a number to a power, just make it an answer. 2 to the 3rd power, we can just make that 8. So always a good step to use a calculator there. Subtract 1 from both sides. Divide by 2. And we'll get x equals 3.5. Or 7 over 2. Both of those are okay. So at this step, very, very important. Take x equals 3.5, check the domain. I want to make sure we don't get any negative logs here. So 4 plus log base 2 of 2 times 3.5 plus 1 equals 7. And we can see 2 times 3.5 is 7 plus 1, which is 8. So the log base 2 of 8, that is a positive log. That is in our domain. We're happy. We checked it. 3.5 is in our domain. So similar idea here for the second one. So going through this one, I will do this one because it's a little bit of a tricky thing here. We want to get the logs on the same side. So if we have 2 logs or more than 1 log, any amount of logs, get them all over to the same side. So this will be our log side because we already have log of x minus 3 over here. So we want to take this log and we want to move it to the other side. So the opposite of minus log x is plus log x. And again, we'll do that on both sides. So this eliminates here and we're just left with 1 on the right side. Just like the previous types of questions, if you see multiple logs, want to simplify them, want to put them together into one single log. We have a multiplication problem here because of the addition. So we'll have log of x times x minus 3, and that will equal 1. So now that we have our log combined to just a single log, we can go back to our exponential powers. So here, common log, if there's nothing written in there, we can pencil in that 10, and we can do 10 to the first power is equal to x times x minus 3. So in this case, 10 to the first power is just 10. X times x minus 3, we can distribute, or we can use a 1 by 2 box. Either of those are okay. We'll have x squared minus 3x will be our resulting answer there. And we do have to solve this for x. So remember, if we see x squared and we have a constant, most often we're going to see that we can either quadratic formula, box plot, any of the above. So we can take our 10, move it over to the other side. We'll get 0 equals x squared minus 3x minus 10. We can put this into a box, see if that factorization works. And after putting it into a box, we should get x minus 5 and x plus 2. And once we get to this step, we can set individually each of these equal to 0. So we should get x equals positive 5 and x equals negative 2 as 2 possible answers. Now, we want to make sure, though, with positive 5 and negative 2, especially if we ever see a negative answer, we want to double check. We want to make sure that that does work in our domain here. So we can have the log, again, positive 5 and negative 2 of 5 minus 3. So here, 5 minus 3 is 2. So x equals 5 is good. And then let's try it for negative 2. So log of negative 2 minus 3 equals 1 minus log of negative 2. Well, we already know that doesn't work, and this one's also negative. So log of negative 2 is not in the domain. So the only solution that truly works here that is in the domain is x is equal to 5, and that's the only answer that we need for that question. So a couple of things for today. I would say the big takeaway is pretty similar solving to the previous unit, just some well-defined steps and some guidance on how to solve. The one change that we're going to see here is when we are solving, we do have to go back, double check, and make sure that answer is in the domain. So some practice questions will help. That's the best way to go through these, is as many as you can get done. That'll be a huge help